All right, we're back. We are in, what are we in? Notes 4 of Calc C. We're on page 5, and we are taking a look at a problem that I guess in theory has something to do with geometric series somehow, because it's the only one we're really talking about. If you look at it, you can see that it definitely has something to do with geometric series, right? Because to get from this term to this term, what I need to do is multiply by negative x. Then to see if it's geometric, do I do the same thing to get from here to here? I do. Do I do the same thing to get from here to here? I do. So this is definitely geometric. It has a first term of x squared, and then it has a ratio of negative x. So I don't know if that's going to be relevant. I imagine that it will be, but we'll see. So first question, determine whether f of x has a maximum, minimum, or neither at x equals 0. All right, so when you are dealing with series, like your inclination in general, when you forget that I said the series thing, in general, when you're doing these problems, your inclination is almost always going to be to use the first derivative test. Let me tell you, when you are dealing with series, the second derivative test is like your best friend, because it's really hard to do a number line test on something that's infinitely long, and you have to like work out like what's going on to the left, what's going on to the right. Second derivative test though, sometimes that works out nicely. So let's see how it does here. So f prime of x. So we'll learn eventually these are called power series. Partly the power rule, I mean, you're just adding a bunch of power functions, that's why. But the power rule works on them, and it's amazing. So when you're finding the derivative of these things, the only rule you ever really need is the power rule. It's fantastic. Sometimes you need a little tiny chain rule, but like, you know, when do you not? So this will be 2x minus 3x squared plus 4x cubed minus 5x to the fourth plus dot, dot, dot. So f prime of 0 is definitely 0. And I know that because everything has an x, and when I plug in 0, I'm just adding up 0 over and over. So f double prime, 2 minus 6x, 12x squared, 20x cubed, plus dot, dot, dot. So f double prime of 0 is going to be 2. And so we know that f prime is equal to 0, f double prime is greater than 0. So I'm going to say since f prime of 0 equals 0, and f double prime of 0 equals 2, which is greater than 0. So that's concave up, right? So I'll say f of x has a relative minimum at x equals 0. And then you could say by the second derivative test. I almost never say that. Like I just write the requirements and then move on. There's space though to the right there. I'm not going to do it. All right, what function? No, write a function g of x. I don't know. Why do I do this on this page? This g of x nonsense. Whatever. Write a function g of x that is equal to f of x on f's interval of convergence. So we said before that we think this is geometric. We think that the first term is x squared, and we think that the ratio, which is, where's my, okay, r is negative x. So that means that f of x should be the first term, which is x squared, over 1 minus the ratio, which would be x squared over 1 plus x. And then our interval of convergence would be the absolute value. We need the absolute value of r to be less than 1, so we need the absolute value of negative x to be less than 1. So the absolute value of x less than 1. The absolute value just kills that negative sign. So again, I hate this question because of the g of x thing that I, for some reason, put in. Therefore, g of x, I guess, is x squared over 1 plus x, where the absolute value of x is less than 1. You'll find out with geometric series, like I don't know exactly like how much depth to go into this because I've never really looked at it, but so this series is centered at 0, and you can tell that because there's no like quantity x minus 5, which would mean that it's centered at 5, or quantity x plus 7, so it's centered at negative 7. It's all just x's, x squared, x cubed. So it's centered at 0. And then the function that we get has a vertical asymptote at x equals negative 1. So if you're centered at 0 and you can go to negative 1, that means that that's going to be your interval. Like you can only go 1. So you can always go from the center to the vertical asymptote. I mean, is there like more to that? Probably, but I've never I don't even know where I would start, like looking into it or like explain. I mean, I guess, why is that? I don't know 100% know. Like, there's probably a really obvious reason. I don't know. All right, so let's write out f of 1/3. So f of 1/3, because I think people don't really look at these enough. Like, you got to look at what they look like to get used to them, right? So we're starting at squared, so it's going to be 1/3 squared minus 1/3 cubed plus 1/3 to the 4th minus 1/3 to the 5th plus dot dot dot, right? Now, subbing 1/3 into f of x should be exactly the same as subbing 1/3 into this function that we found, because 1/3 is, the absolute value of 1/3 is less than 1, so it converges. So if we just take 1/3 and sub in 1/3 squared, 1 over, I don't know what I'm saying, but you should do that. And then, so this will be 1/9 over 4/3, which is 1/12, I think. So 1/12 is what I would expect to get if I evaluate the function at 1/3. So, you know, I might like try to use the calculator to get some of these. I don't know how it's going to deal with this summation that I'm going to write, but I'm going to do it. And then use your function to evaluate the series. So this is a really interesting idea. I really like it. Once you sort of understand how geometric series work, you can use them to find things that you might not expect, right? So this is not exactly the same as f of x. And if you're really not sure what's going on, replace the 1/2 with x and just look at what you get, right? 2x minus 3x squared, 4x cubed, is 5x to the 4th plus dot dot dot. Well, what does this look like, right? Go back to the original. We had x squared and we end up with 2x. We had minus x cubed minus 3x squared plus x to the 4th plus 4x cubed. I think you can see what this is. This is actually just f prime, right? So this is f prime of x, which means that if I take the function that I found, so to evaluate this, if I take this function that I found, find its derivative, and plug in 1/2, it should give me the sum of this series. So that's what I'm going to do. It's just kind of like a really neat application. So we said that, I'm going to change it back to f of x. We said f of x was actually x squared over 1 plus x, provided that the absolute value of x is less than 1, which is a big deal. Like, you need that to be true. So f prime of x, a little quotient rule problem, bottom, derivative of the top minus top, derivative of the bottom, all over the bottom squared. So can I just find f prime of, so this we were finding f prime of 1/2. That's the thing we're trying to find. So if I plug in 1/2, I think it's like I could keep simplifying, but I think plugging in 1/2 here is probably good enough. I mean, I might really regret that. I also might not. Let's see. So what are we getting? 3/2, so 6/4, 5/4 over 9/4, which would be 5 over 9. I think the sum is going to be 5 over 9. So the thing is, it's like really hard to convince you. If you don't believe that, it's very hard to convince you of that, because like that's sort of the way we need to evaluate it. I'm going to try on the calculator to get some of this to work. So let's see. I mean, I can write a summation and use like some of the terms, but like that won't be enough. I don't know. Let's see. So what do I want to do? I want to do f of x is, let's just see what happens if I try this. I'm going to go from 0 to infinity of x squared times the quantity negative x to the n. So when n is 0, we get x squared. When n is 1, we get negative x cubed. When n is 2, we get plus x to the 4th. So this is f of x. Will it do something with that? It won't. Okay. So we'll take the derivative. Let's just do the derivative at x equals 0 and see what happens. Oh, gross. This isn't doing anything for us. Will it evaluate f of What do we do? F of 1/3. Okay, F of 1/3 I found, so that's good. Let me change it to just like, so this is the thing you do with series. You start looking at partial sums. Let's just change it to like 10. And then now what is it? Okay, so I could do the derivative of f of x such that x equals 0. I can do the second derivative of f of x when x equals 0. You can see like, so we're getting the 0 and the 2 that we got. I don't know how compelling that is. And the derivative certainly won't work. But how about this? What if, so graphs are definitely your friend when like task type things stop working. So here's f of x. All right, whatever. Here's what we think the sum is. And you can see, let's change our window so that we're like in the interval of convergence, right? So the interval of convergence is -1 to 1. So let's do -1.1 to 1.1, I guess. And you see like really, really good fit on that interval. So let me just check and see if the derivative, what am I doing? Derivative, okay, my sum is x squared over 1 plus x. So I want the derivative of that when x equals 1/2. And we get 5/9, which is what we had gotten. So I don't know how compelling that is other than potentially the graph. The graph can be very compelling evidence that you have done it correctly. So I definitely recommend that you take a look at those. This is a pretty standard problem where you're just asked to like, not just write a series, not just look at a series, but like do things with it, right? Is there a maximum? Is there a minimum? You're going to use second derivative test a lot. Write a function for the closed form, right? So instead of having like this summation thing, you're just going to get a really nice function that you can work with, and then work with the function, right? So when you're told to evaluate a weird series, think to yourself, do I know a function that this converges to? Because if so, it'd be much nicer to work with a function. And that's what we did. And then just kind of recognize a derivative. So I mean, like, you could be asked about the second derivative. That'd be gross. But if you look at it, like here, the second derivative is going to be super easy to find. It's 2 minus 6x plus 12x squared minus 20x cubed. So if you saw that, you might be like, well, what if I integrated it? And then you get something. You're like, well, what if I integrated that? And then you'd be back to your function. You'd say, oh my God, this is the second derivative, and go from there. So anyway, I like problems like this. I hope you kind of enjoyed it, and I will see you in the next video.